Hello children, welcome to ChemSol. Today onwards we are going to start about the crash course for ICSE grade 10. First topic I am talking about is alkenes. So since this is a crash course, I am covering all the important types of questions and points. Starting with, in the alkanes, the general formula will be CnH2n plus 2. This will be the general formula. Here, for example, what is N? N is the number of carbon atoms. So if you put N is equal to 1, you will get first member C1 H2 plus 2 into 1 plus 2, 4, CH4. N is equal to 2 if you put C2 H6. N is equal to 3, C3 H8. Alkanes are homologous series. In the homologous series, the successive members differ by CH2 group. If you see here the difference between these two, CH2, these two is CH2. The common names of the compounds you have to know here is methane. Methane is commonly called as marsh gas. Marsh gas. This is also a greenhouse gas. Question: which hydrocarbon is called, or which hydrocarbon is called as marsh gas, or which hydrocarbon is greenhouse gas? Marsh gas, because it is obtained from the marshy places. Marshy places. Ethane has no common name. IUPAC nomenclature, I will take another session for that. Next, talking about the MOP. MOP means method of preparations. There are two methods of preparation for alkenes. First method is decarboxylation, second one is reduction. Decarboxylation, what we do is we use the reagent soda lime, which is a mixture of two bases, sodium hydroxide and calcium oxide. What is the role of calcium oxide here? The sodium hydroxide is deliquescent in nature, so calcium oxide will reduce the deliquescent nature of sodium hydroxide. As you also know that calcium oxide is it is a drying agent. What starting materials we will take here? Sodium acetate. For methane we will take sodium acetate. Formula CH3COONA. CH3COONA plus NaOH in presence of calcium oxide and heat 300 degrees Celsius. What we have to do here? Remove the sodium carbonate. This part. Remove the sodium carbonate. CH3 and H will become CH4 gas and will get sodium carbonate, Na2CO3. Why it is called decarboxylation? Because the COO, that is CO2 group, is removed from this salt. So any reaction, any organic reaction in which carbon dioxide is removed, that will be called as decarboxylation reaction. This is for preparation of methane. Ethane, if you take, see, simple trick I will tell you. Methane and ethane, what is the difference? CH4, C2, H6. There is a difference of CH2 group. Means you should add a CH2 group extra to what? To your starting material. Now what you took here is sodium acetate is the common name. IUPAC name will be sodium ethanoate. So you have to add one CH2 group extra between this carbon and this carbon. Then what you will doing, you are adding one extra carbon atom in this, so you will get this CH3 CH2 COONA, CH3 CH2 COONA, plus other things are same, sodium hydroxide, calcium oxide, 300 degrees Celsius. Remove sodium carbonate. What is there? CH3 CH2 and H. If you club them together, you will get C2H6 and sodium carbonate. This is how you prepare methane and ethane. Point to remember here. Okay, methane, ethane gases collected by downward displacement of water. Method of collection for these gases is downward displacement of water. Talking about the second method, reduction, what reagent we use here? We use metal, zinc copper couple in alcohol. Zinc copper couple in alcohol. So this metal in alcohol will produce nascent hydrogens. Nascent hydrogen is nothing but it is a hydrogen atom. We represent it by like this, writing the H in square bracket. So what happens? This is not so stable. It will form for a small fraction of second. So it will immediately react with our starting material. Here, what is the starting material we are taking? To make the methane, you can take CH3I, which is methyl iodide. That is a common name. Common name I am writing here. Both are important. Methyl iodide is a common name. IUPAC name is iodomethane. Iodomethane. What zinc copper couple in alcohol will give us? Hydrogen. Which hydrogen? Nascent hydrogen. So we will write nascent hydrogen 2. 2 hydrogen atoms we need. And on the arrow you have to mention the condition, that is zinc copper couple in alcohol. Alcohol here is a solvent. So what you do? Break this like this. One H you give to CH3, another H you give to I. So what you will get? CH3 plus H, CH4, H plus I, HI. Hydrogen iodide you will get, not hydrochloric acid. So this is methane, this is hydrogen iodide. Similarly, if you want to get ethane, what you have to do? Add one CH2 group here. It can be ethyl iodide, ethyl bromide, ethyl chloride. Anything is fine. So I will take C2H5Br, or you can also take C2H5Cl. So with nascent hydrogen, same condition I am writing here, 2H, 2H. Condition is same, zinc copper couple in alcohol. So what you will do? One H you give to C2H5, it will become C2H6. Another H you give to Br, it will become HBr. Same thing happens here, C2H6 plus HCl. Hydrogen chloride, hydrogen bromide, hydrogen iodide we get here. Why it is called reduction? Because you are adding hydrogen atoms. That's why it is called as reduction. Okay. One give reason question is, why we use soda lime? Why not simply sodium hydroxide? I told you sodium hydroxide is deliquescent. Next, talking about the chemical properties of alkanes. First chemical reaction we are studying is combustion. Combustion is nothing but burning, the reaction with oxygen. There are two things here. What is that? One is complete combustion. Another one is incomplete combustion. What it depends upon? It depends upon how much oxygen is available. So excess of air. So here limited amount of air. What are the changes? Whenever you burn hydrocarbons, what I am telling you, whenever you burn hydrocarbons, alkanes, alkenes, alkynes, they all are hydrocarbons. When you burn them, you will always get carbon. See, hydro means hydrogen, C means carbon. So carbon and hydrogen are there. It will react with the oxygen. Burning means carbon plus oxygen, carbon dioxide, hydrogen plus oxygen, water, CO2 plus water. That is in case of complete combustion. So what are the products you will get here? Products, we will write here products. water and carbon dioxide. What about here? Incomplete combustion leads to the formation of carbon monoxide and water. What is the problem? The problem is with carbon monoxide. Carbon monoxide is poisonous. You know the effect of that? It combines with the hemoglobin, forms a stable complex called carboxyhemoglobin and reduces the work of the hemoglobin, and that will lead to unconsciousness and eventually death of the person. Talking about the reactions of methane and ethane. So first let's take the methane. Combustion with oxygen gives you, complete combustion will give you CO2 plus H2O. Balancing trick. You keep the oxygen at the last. What do you do? First carbon and hydrogen you balance. Carbon is 1, hydrogen are 4, here 2, so make it 2. Now oxygen, now you count 2 plus 2, 4, so make it 2. This is simple. Second one, C2H6 plus oxygen, CO2 plus H2O. Again carbon 2 here, make it 2, hydrogen 6 here, make it 3. Count the oxygen, 2 into 2, 4, plus 3, 7. So what you have to do here is 7 by 2 you write. 7 by 2. To remove this 2, this equation you multiply by 2. Whole equation you have to multiply by 2. Then what you will get? 2 into C2H6. 7 by 2 into 2. 2 to get cancelled. 7O2. 2 into 2. 4CO2. 2 into 3, 6H2O. This is how you balance this. Same way you can write for carbon monoxide also. Methane, incomplete combustion, that is insufficient amount of air or limited amount of air, you will get CO plus H2O. First balance the carbon, 1, 1, hydrogen 4, here 2. Oxygen 2 plus 1, 3, right? What you have to do? You can't do that 3, so 3 by 2 you do. Then multiply this whole equation by 2. So what you will get? 2CH4 plus 3 by 2 into 2, 3O2 gives you 2 into this CO plus 2 into 2, 4H2O. So this is the first reaction, combustion. Write down. Okay, next type of chemical reactions, a substitution. What is the meaning of substitution? Alkanes are, we know that alkanes are saturated hydrocarbons. Means all the 4 bonds of carbon satisfied by single covalent bond. So they will undergo only substitution, not addition. Substitution means you have carbon with 4 bonds and you have hydrogen here. This hydrogen will be replaced by the halogen. Say for example halogen if I represent by X2. So what happens here, under certain conditions this H is replaced by this, you will get CX plus HX. That's called substitution reaction. What are the conditions we need here is sunlight. We need higher amount of energy because saturated hydrocarbons, those are alkanes, are less reactive because it is already saturated. Its 4 bonds are single covalent bonds. It is less reactive. Therefore, we need to give the energy in the form of sunlight, UV light, or heat it to higher temperature. Talking about the methane first. Methane plus, I can add here chlorine, Cl2, under any of these conditions. Any one you have to write. So I will write here, whenever writing sunlight, write diffused. Sunlight means not direct sunlight. How much amount of energy is needed, we will reduce the intensity of the sunlight by using some filters. That's called as a diffuse sunlight. So what happens here, one of the H you replace by the Cl, so CH3 you write. Okay, that H is replaced by Cl, so Cl plus that H will combine with another Cl, so you will get HCl. Just to show you how it looks, CH, H, H and H. plus Cl, I will write like this, Cl and Cl. So what you have to do, remove this H and this Cl. Under this condition, what you will get, CH3 and this carbon will form a bond with this CH3Cl plus H and Cl, HCl. This is how it works. Okay, but if you see in CH3Cl, which is chloromethane, what is the name? Chloromethane. We have another 3 hydrogens which can also be replaced. So this reaction will not stop at this stage. It will continue until all the hydrogens of methane are replaced. So you have to take that and proceed next. CH3Cl plus Cl2. Under same condition, 1 H you reduce, you write it as CH2. 1 Cl is already there, 1 more Cl you add, Cl2 it will become plus HCl. Dichloromethane. That dichloromethane undergoes further substitution. CHCl3 plus HCl we get. That CHCl3 will undergo further substitution. CCl4 plus HCl we get. The name of this common name I am writing, chloroform. Chloroform. This one carbon tetrachloride, which you know. Okay. So these are the 4 steps. How many hydrogens are there in the given alkane? Those many steps will be there for substitution reaction. So actually we get mixture of all these compounds. I'm telling you first IUPAC name: chloromethane, dichloromethane, trichloromethane, tetrachloromethane. Common name will be methyl chloride, ethyl. Okay, this one will be, no need to know common name. This one chloroform, this one will be carbon tetrachloride. Carbon tetrachloride is a common name. Talking about ethane. So this time I will make it easy for you. Ethane has how many? 6 hydrogens, C2H6. How I will write that? Condition you know already. You have to write the same way. So what we are adding, I will write on the arrow. What products that we get, one of that we will write on the bottom. Say for example, what you are adding? Cl2. That is a reactant. What you will get? Substitution. One of the hydrogen is substituted by Cl. C2H5Cl plus HCl. So that I will write here as minus HCl. If you write here, means it is in the product side. So this further will undergo same thing, plus Cl2 minus HCl. If you do C2H4Cl2, proceed further, plus Cl2 minus HCl, C2H3Cl3 plus Cl2 minus HCl, C2H2Cl4 plus Cl2 minus HCl, C2HCl5 plus Cl2 minus HCl, CCl6. That's the final product. Okay, so how do you name these? Ethane, chloroethane, dichloroethane, trichloroethane, tetrachloroethane, pentachloroethane, hexachloroethane. No need to remember any common names. Okay, but IUPAC names are important. So overall 6 steps we have. Same reactions we also do for bromine. Okay, same reactions for bromine. Means you will get here bromomethane, dibromomethane, tribromomethane, tetrabromomethane. Same here. No, we don't perform this reaction with F2. Not performed with fluorine. Why? Because the reaction is explosive in nature. The reaction is explosive in nature. For iodine, reaction with iodine, the reaction is reversible. The reaction is reversible. Okay, so no need to worry about that, just remember these points. So chlorine, bromine, these two reactions you have to know, and the IUPAC names. Common name for chloroform carbon tetrachloride. Okay, note this. Okay, let's see some questions here. Convert methane to chloroform. So if you see, methane is CH4, chloroform is CHCl3. Therefore, you should also know the common name. So what is the condition here? So you will add chlorine in presence of diffused sunlight. Diffused sunlight. So first you will get CH3Cl, not directly this. Correct? So when you further write this reaction, CH3Cl you will take plus chlorine, same condition you will write, diffuse sunlight, CH2Cl2 plus HCl, here also plus HCl. Okay, then you will take this CH2Cl2 plus Cl2 under same condition, CHCl3 plus HCl. Okay, if it is asked for 3 marks, say it is only for 1 mark and they don't mention that write in 3 steps. So what you can do is simply take methane plus Cl2 you do under diffuse sunlight, chloroform you can write plus HCl. So what you have to do, you have to balance it. Okay, overall you need 1, 2, 3 moles of Cl2, and how many you got? 3 moles of HCl. And if you see, it will be balanced. 4 hydrogen, 3 plus 1, 4 hydrogen, chlorine 3 into 2, 6, 3 plus 3, 6, carbon is 1. That is for 1 mark. Second one, sodium acetate to methane. This is preparation of methane. So methane will be on the product side. Many children will have confusion which reaction we have to write. Remember, you have to categorize it, method of preparation and chemical properties. So first one was chemical properties. This one is method of preparation. You have to see what are the two methods: decarboxylation, zinc copper couple in alcohol. Since we are using sodium acetate, that should be decarboxylation. So what is that? CH3COONA plus what we use in decarboxylation? Soda lime, NaOH. So soda lime, calcium oxide you will write on the top, 300 degrees Celsius. You will remove sodium carbonate, right? So plus Na2CO3. Got it? Ethyl iodide into ethane. Again, ethane is on the product side. Means you have to check for method of preparation. Here ethyl iodide, if it is there, it will be zinc copper couple in alcohol. So C2H5 iodine, so I plus what they will give us? Nascent hydrogen. Which one? Zinc copper couple in alcohol. They will give us nascent hydrogen. So one hydrogen you give to C2H5, another hydrogen you give to I. So you will get C2H6 and hydrogen iodide. Okay, write this.